Let's go over a few examples on solving one-step equations. Let's start with this one. When I read this equation, I'm going to start with the variable x. X minus 5 equals 2. Another way to say this would be x decreased by 5 equals 2, or x diminished by 5 is 2, or 5 less than x is 2. And we have that equation here, which you learned those keywords last year in grade 6, all those keywords for translating English into algebra. We are not going to do that. We're just going to start with the algebra and solve this equation to figure out the solution. I know a lot of you are looking at this and saying, I know the solution. It's obvious. 7 minus 5 equals 2. So why do we have to do all of this work and showing our thinking when I can just tell what the answer is in my head? And my reason is because it's going to get a lot more difficult. Let me show you an example. So you're eventually going to be solving multi-step equations in the future, not this year, but next year. And when you do so, you have to be very organized and systematic with your thinking. So you can see here that there is some inverse operations involved where if you see a minus 16, I added 16 to both sides to undo this term. And then we get down here to this one-step equation, and it says 20 times x equals 60. So you have to divide both sides by 20 and use the inverse operations to get x equals 3. But my point being is that it's going to be a lot more difficult than just a one-step equation in the future. So we're going to start with the basics, but using the same practice you will be with those harder ones from the get-go, so you're ready for it. So we're going to just add 5 to both sides. Okay, I like to put a little line down with my equal signs to keep myself organized. And when I add 5 to both sides, what happens is I have a negative 5 and a plus 5, and those cancel out to make 0. So on the left, it's just x plus 0 equals 7, or x equals 7. So you can substitute that back in to check it. Does 7 minus 5 equal 2? Yes, 7 minus 5 equals 2. So we got that one right. Next, I'm going to just look at what operation I'm dealing with the variable. I have x plus 8, or 8 added to x. The sum of x and 8, those are all the keywords from last year. The sum of x and 8 is equal to 3. We're going to subtract 8 from both sides to isolate the variable. Now be careful because subtraction is not commutative. You're subtracting the 8 from the 3, not the 3 from the 8. So be careful over there on that right side. So if I'm subtracting 8 from both sides, those clear. I have x plus 0, which is just x. Okay, this is 0 here. X equals, and this is a negative number. This is negative 5. So when I check my solution, I'm going to plug this in, substitute it in, that value for that variable, and check it. So does negative 5 plus 8 equal 3? Yes, because negative 5 plus 8 is 3, and 3 equals 3. So that checks out. My next example, I've got negative 4 times x, this is multiplication, equals 20. This is similar to what we did with cross products. We were solving these one-step equations that look just like this, these multiplication one-step equations with solving proportions for a very long time. So this one should come very naturally to you by now. You're just going to divide both sides by negative 4. Okay, negative 4 divided by negative 4 is 1. So over here on the left, we have 1x, 1 times x, equals negative 20 divided by negative 4. That's negative 5. sorry, did I say negative 20? Positive 20 divided by negative 4 equals negative 5. So we have x equals negative 5. And my original equation was negative 4 times x equals 20. So if I wanted to check that, I'm going to replace this variable x with a negative 5. That's called substitution. And a negative times a negative is a positive. 20 is equal to 20. So that is correct. I know these seem like very simple to do mentally. Why do we have to do all this work? But just bear with me because it's going to get harder. So practice like this with the easy ones. So once we get to the hard ones, you have the skill. All right, so we're going to multiply by 7 on both sides because this x here is being divided by 7, and the inverse of division, or the opposite operation of division, is multiplication. So now look on this left side. Look what happens here. When I'm multiplying a fraction times a whole number, remember we can make this an improper fraction, and then 7x divided by 1 times 7, which is 7, I'm going to have this situation where my 7s are canceling out. So when you're multiplying fractions, you multiply your numerators, you multiply your denominators, and then you simplify. But I would prefer if you simplify before you multiply, just like we did with fraction multiplication. So I can simplify factors here on the left, and what's happening is all I have left is 1 times x divided by 1. That's just all canceling out to make 1x. Okay, so I'm just going to put that x here. So I officially have isolated the variable on my left side, and now I need to simplify what's on my right side. And there you have it. And of course, you can substitute that back into the original equation and see if it makes a true statement. All right, this one's a little more tricky. So we've got a fraction times a variable equals a number. So you may be able to do this one mentally if you know 2/3 of some number is equal to 12. Well, 2/3 of what number equals 12? Can you think of that? Another way to do this is you could divide both sides by 2/3. That might make the most sense to you since this is multiplication. But remember, when you divide by a fraction, you're really just multiplying by the reciprocal. So my first step here would be to multiply both sides by the reciprocal of 2/3, and that way you can get at your answer very quickly. Okay, so if I multiply both sides by the reciprocal of 2/3, look what happens here. These 3's cancel out to make 1's. These 2's cancel out to make 1's. So this is all canceling out to be x on the left. And then I've got some side work to do over here because 12 times 3 over 2, I have to simplify. So let me do some side work down below. 12 over 1 times 3 over 2. So I've got 6 times 3 in my numerator and 1's in my denominator. So this is 18 over 1, which is just equal to 18. And there's my solution. So my original equation, let's check this one. My original equation was 2/3 of x. I'm just going to put parentheses in there, equals 12. So here's where my x was. I'm going to replace that x with 18. Is 2/3 of 18 equal to 12? Think about that using mental math. 1/3 of 18 would be what? What's 1/3? 1 out of 3 parts of 18. Can you think of it? Did you say 6? If you said 6, you're right. So 1/3 of 18 is 6. So 2/3 of 18 would be 12. So that makes a lot of sense. And if we showed this using numbers and operations, it'd look like this. So 2/3 times 18/1. I simplified factors here, dividing out 3 here and 3 here. Oops, made a mistake. So if I divide this by 3, if I divide 18 by 3, nope, I'm good. All right. So always double checking. If you need to rewind and watch that one again, you can. All right, one last problem here. Okay, think about this one. What do you think? If you thought that you were going to either divide both sides by -1 or multiply both sides by -1 to solve this, you're correct. There is an understood 1 here, right in front of this variable. We don't always write it. We just know it's there. It's like an invisible 1. So if I wanted to solve this and isolate this variable x, I have to undo the -1. And you can either multiply both sides by -1 and do it like that. I'll show you how that works. Okay, a -1 times a -1 is what? It's just a 1. So we have x on that side. And then on the right side, we have -16. Another way to do this, which might be more intuitive, is to really still be using those inverse operations. And since we're multiplying x by -1, your brain may tell you, well, then I'm going to divide by -1 because the inverse of multiplication is division. Okay, and in doing so, yes, these will cancel out. So you'll just be left with x equals -16. Okay, so either way works. And that's all I have for you today. Feel free to watch this video as many times as you want to. And email me with questions at the end of this presentation if you have them.